Hello, hello. Welcome back to all the students. I am Captain Ray Sanju. Welcome to online classes from Department of Chemistry, Government Degree College, Peddapalli. In the last class, we discussed about introduction of alcohols and phenols, and we also completed some of the preparation methods of alcohols. Today we are going to discuss about the remaining preparation methods of alcohols. First, we'll discuss uh, preparation from alkyl halides. Here, preparation from alkyl halides. This is the alkyl halide on reaction with the strong nucleophile, strong base, that is sodium hydroxide. In this sodium hydroxide, OH minus nucleophile replaced the Cl minus. Okay. Alcohols can be prepared by substitution reactions in which a leaving group is replaced by hydroxyl group. Here, hydroxyl group, the strong base from strong base sodium hydroxide, that particular hydroxy group replaced this Cl minus ion. Replaced. Here we are getting alkyl. This is the alkyl chain. It is attached with the alcohol. Finally, we are getting alcohols, monohydric alcohols. It is a this reaction proceeds in a single step in based on this strong nucleophile, because it is called as SN2 reaction, SN2 mechanism. Primary substrate will require SN2 condition. SN2 condition, generally the reaction proceeds in presence of strong nucleophile. This type of strong nucleophile. While tertiary substrate, this is the primary substrate, the starting compound, primary. This is the tertiary substrate will require SN1 condition. SN1 condition, this type of reaction proceeds in presence of weak nucleophile. Weak nucleophile, here we are using water molecule. Water molecule. Okay. Is it clear? We are using water molecule. In presence of this particular water molecule, this reaction proceeds SN1 mechanism. In SN1 mechanism, it is a two steps reaction. In this mechanism, this particular OH minus nucleophile replaced this Cl minus nucleophile. Here, formation of HCl. This is the alcohol, monohydric alcohol is produced in this particular reaction. Is it clear, all of you? Monohydric alcohols preparation are based on SN2 mechanism and SN1 mechanism. Okay. From alkenes or from olefins, this type of reaction. Here, olefin or alkene, propylene, propene, on reaction with the first from alkenes in presence of this particular dilute sulfuric acid. In presence of this particular dilute sulfuric acid, acid catalyzed hydration reaction. Here finally we are getting isopropyl alcohol, isopropyl alcohol, branched type of structure. In presence of this particular dilute H2SO4, it gives a intermediate hydrogen sulfate intermediate. This particular intermediate on hydrolysis will get alcohol. This finally compound we are getting alcohol. In the second type of reaction, here mercuric acetate and hydrolysis in presence of NaBH4, sodium borohydrate, sodium borohydrate. Here also oxymercuration and demercuration reaction. Finally we are getting same type of isopropyl alcohol. The same starting material, propylene, this compound on reaction with the boron trihydride, BH3, in presence of tetrahydrofuran, hydrogen peroxide and sodium hydroxide we are using. Here in this reaction, in the intermediate tripropyl borane is formed as an intermediate. This particular intermediate on reaction with the hydrogen peroxide, from that intermediate we will get 3 moles of alcohols produced from this reaction. This reaction is named as hydroboration and oxidation reaction. Hydroboration and oxidation steps are involving in this particular reaction. Finally we are getting monohydric alcohols. Is it clear, all of you? Okay. Now let us go to reduction reaction. Reduction reaction, the conversion of a ketone or aldehyde to an alcohol is a reduction. Generally here reducing agent we are using platinum or palladium, nickel. In presence of this particular reducing agent, addition of hydrogens, reduction in this particular reduction reaction, here addition of hydrogens. Here in this carbonyl carbon, C and O pi bond cleavage takes place. This oxygen atom gets negative, that negative oxygen, and here also hydrogen. This particular CO, addition of hydrogens, this reaction is called reduction reaction in presence of reducing agent. These are all platinum, palladium or nickel. In presence of these reducing agent, here on reaction with the hydrogen, here also same, this CO pi bond cleavage takes place. This particular C double bond O, this pi bond cleavage takes place. Oxygen gets negative. Okay, here addition of hydrogen. This particular reaction is called reduction reaction. Uh, in these two reactions we are getting monohydric alcohols, isopropyl alcohol and cyclopentane ring cyclopentyl alcohol. Okay, cyclopentane ring are attached with the hydroxy group. This particular product we are getting more yield, 95 percentage product we are getting from this reaction. It is a more yield, more yield we are getting from this reaction, reduction reaction. Okay, now let us go to another uh, type of reducing agent we are using here, sodium borohydride. Sodium borohydride reducing agent we are using. Sodium borohydride is another common reducing agent that can be used to reduce ketones and aldehydes. Here, this is a ketone. Generally, this sodium borotetrahydride generally used for reduction of ketones or aldehydes. Here we are using ketone. Okay, this particular ketone in presence of this, the sodium borotetrahydride reducing agent. Here these are the solvents, ethanol, methanol or water. In presence of this solvent and on reaction with in presence of this particular reducing agent to converted as monohydric alcohol. This monohydric alcohol is also we are getting more yield, 90 percentage of the product we are getting from this reaction, more yield. Okay, okay, is it clear all of you? Okay. This is the mechanism part of this particular sodium borohydride reaction. This is a actually single step reaction. How the sodium borohydride involving in this reaction, how the carbonyl that particular CO pi bond cleavages and sodium borohydride in what way involving, uh, how the product may obtain, we'll discuss clearly here. Mechanism of this particular reaction. Sodium borohydride functions as a source of hydride. It is a source of hydride H minus ion. It is a source of hydride H minus ion. And the solvent here, so borotetrahydride. From this borotetrahydride here, loss of H minus, this BH bonded electron shifted to hydrogen. That hydrogen gets negative. That H minus ion attacks on carbonyl carbon. Okay, because this step is called as nucleophilic attack. Nucleophilic attack. That particular H minus ion is produced from any NaBH4 sodium borohydride. That nucleophile attacks on carbonyl carbon. In this nucleophilic attack in the first step, sodium borohydride delivers H minus to the carbonyl group. Carbonyl group, carbonyl carbon. Immediately this pi bond cleavages and oxygen gets negative. Here oxygen gets negative charge. That particular H minus nucleophile attacks on carbonyl carbon. Here we are representing with a red color new substituent. It is a red color we are representing. Okay. Next, in the next step, we are using water molecule, that solvent. Solvent. In this reaction, we may use water or ethanol or methanol solvent we can use. Okay. This second step is called as proton transfer step. Proton transfer step. That proton transfer from water molecule. Here this O minus abstract hydrogen from water molecule. Okay. Form a OH bond. OH bond. Finally we are getting monohydric alcohol we are getting, but this H minus attacks on this particular carbonyl carbon, and here also H alcohol, the resulting alkoxide ion. This is the intermediate alkoxide ion. This alkoxide ion is then protonated to form an alcohol. This is an alcohol. Alcohol we are getting from this reaction. Okay. This is the clear information. This is the mechanism part of this particular reduction reaction with the sodium borohydride. This is the last reaction. This is the sodium borohydride. Is it clear, all of you? This is the mechanism part. Another type of reducing agent. Now we will discuss another type. Instead of that sodium borohydride, this is the another type of reducing agent, lithium aluminum hydride. It is also called as lithium aluminum hydride is another common reducing agent, and its structure is very similar to sodium borohydride. Okay, is it clear? Here please observe, it is very similar structures. Both the reducing agents are very similar. Here the difference, please observe, in the center atom here boron, here the center of the atom aluminum. Both these atoms are gets negative charge. Around this negative charge rotates the positive charge here sodium. Here this negative charge, around the negative charge rotates lithium, always lithium plus. Okay, lithium plus electrophile rotates around this negative charged species. Okay, this is called lithium aluminum hydride or La. The first structure is sodium borohydride. These two structures are very similar with each other. These two are reducing agents generally used in these organic reactions for reduction. Is it clear, all of you? Is it clear? In these two structures? Okay. In presence of this particular law, how the reaction takes place, we'll discuss. One of the example we'll discuss. Law. Lithium aluminum hydride is a common abbreviated either as La or as lithium aluminum tetrahydride. This is the formula. Lithium aluminum tetrahydride. Okay. It is also delivery agent of H minus. In the last case, sodium borohydride is also delivering H minus nucleophile. That particular nucleophile attacks on carbonyl carbon. Here also this particular reducing agent is a delivery agent of H minus. Okay, but it is a much stronger reagent when compared with the sodium borohydride. It is a stronger reagent. It reacts violently with the water. This reaction, that second step of reaction with the water, it is a violent reaction because in what way we will use, please concentrate. And therefore, a protic solvent can be used present together with the La in the reaction flask. Okay, that second step of um, proton abstracting step, that is that should be reaction. In the second step we will discuss in the mechanism part. Here we should use very carefully. First, the ketone or aldehyde is treated with La. Here in this reaction we are using aldehyde or ketone. We can use aldehyde or ketones generally treated with the La, and then in a separate step the proton source is added. Here we are representing H2O. H2O we are generally used in the second step. It is a single step. We are showing in a single step reaction. In reaction mechanism part we will see actual that proton source, this particular water molecule where we use, we'll see. Proton source is added to the reaction flask in a separate step. Water H2O can serve as a proton source. This particular water is a proton source. It gives H plus ion. Okay, that H plus ion generally abstract in the second step. Although H3O plus hydronium ion can also be used as a proton source. Here this water molecule, or instead of this water molecule we can also use H3O plus, H plus and H2O in hydrolysis in presence of acid. Okay, H3O plus we can also use hydronium ion. Here please observe, this is the normal chain and the terminal carbon, the function group is aldehydic function group. In presence of La and for the reaction proceeds on hydrolysis, will get a more yield of monohydric alcohol. Monohydric alcohol, 86% product we are getting from this reaction. In this single step, we cannot understand how the breakage takes place, how law lithium aluminum hydride attacks on reaction with this particular aldehyde will observe in the mechanism part. Okay, here please concentrate. This is the actual mechanism part of this particular reaction. Here we are using ketone or C double bond O or ketone. Instead of this ketone, we can also use aldehyde. Here, if it is hydrogen atom instead of this, or it may be hydrogen. In that case, it is a aldehyde compound. Okay. Here we are using ketone. Ketone on reaction with the La lithium aluminum tetrahydride. This particular aluminum tetrahydride is a delivers H minus ion. H minus ion. Here breakage of this particular aluminum and hydrogen bond, sigma bond. These electrons shifted to hydrogen. Hydrogen atom gets negative. It acted as a nucleophile. This nucleophile attacks on carbonyl carbon. Okay, carbonyl carbon. Immediately, this particular pi bond in between C carbon and oxygen, this particular pi bond cleavage takes place when attacking of nucleophile. This first step, because it is named as nucleophilic attack. Nucleophilic attack. Is it clear? In the first step, La delivers H minus ion, that particular H minus ion to the carbonyl group, attack to the carbonyl group. Oxygen gets negative. Okay, this is the intermediate, alkoxide ion intermediate. Is it clear? Alkoxide ion intermediate. Oxygen gets negative. This particular nucleophile attacks on carbonyl carbon. Okay, this is the intermediate alkoxide ion. This alkoxide ion protonated to form alcohol. Protonated. This oxygen abstract hydrogen from water molecule. This is the second step. In the second step, we are using that particular water molecule. Okay. Otherwise, this water molecule, if we use in the first step, that particular reaction, just now we discussed, that particular reaction proceeds violently with the water. It is a violent reaction because we should use carefully in the second step. Okay, it is a proton transfer step. This particular intermediate alkoxide ion proton abstract from water molecule, it converted as alcohol. Monohydric alcohol is formed from ketone in presence of La, in presence of lithium aluminum hydride. Is it clear, all of you? This is the clear cut mechanism of La reducing agent. Now let us go to various examples of this particular reduction reactions, various examples. Please concentrate here. Here also same ketonic function group, ketonic function group. There is a unsaturation in the cyclic ring. Here ketonic function group. In presence of sodium borohydride, and this is the solvent methanol we are using. In presence of this particular sodium borohydride and methanol, it converted as monohydric alcohol is more yield 90 to 95 percentage. More yield we are getting. Here there is no disturbance of, there is no reduction of this unsaturation in the cyclic ring. This unsaturation as it is in the product. Only there is a reduction takes place in carbonyl functional group. These two reagents generally, it may be sodium borohydride or La, generally used for reduction of aldehydes or ketones. There is no change of other unsaturated pi bonds. Is it clear? This is the difference. In presence of this particular sodium borohydride and methanol monohydric alcohol, and the same reaction proceeds in presence of La and water molecule. In presence of water molecule, water solvent, will get a same percentage more yield, 90 to 95 percentage monohydric alcohol is formed from this reaction based on this particular intermediates, reducing agents, these particular reducing agents. When we go to another type of reduction reaction in presence of these strong reducing agents, for example, it may be platinum, palladium or nickel. In presence of these strong reducing agents, addition of hydrogen, here H2, addition of hydrogen, here the carbonyl functional group and unsaturated pi bond in the cyclic ring is also reduced, here. In presence of this particular strong reducing agent, reduced the two pi bonds here, C in between C double bond O, and in the cyclic ring unsaturation is also reduced. Okay, finally we are getting this type of monohydric alcohol. Here also 90 to 95 percentage more yield we are getting from with the use of this particular strong reducing agents. Okay, is it clear, all of you? Is it clear? Now let us go to another reaction. Here we mentioned that La is much more reactive than sodium borohydride. La is generally more reactive, more strong reducing agent when compared with the sodium borohydride. As a result, La is less selective less selective because it is more reactive and a strong reducing agent because it is less selective. It undergoes very fastly. La will react with the carboxylic acid or an ester to produce an alcohol. But sodium borohydride will not give this reaction. If sodium borohydride on reaction with the carboxylic acid or ester, it does not undergo in the reaction sodium borohydride. But La, it it produces it turns carboxylic acids or esters converted as alcohols. Here please observe carboxylic acid or COOH, carboxylic acid function group compound. This compound on reaction with the excess La, lithium aluminum hydride and water solvent. Here we are getting alcohol, monohydric alcohols. From this, all carboxylic acids also will turns alcohol. This reaction will not give with the use of sodium borotetrahydride. It is a weak reducing agent. Based on that, we cannot we cannot proceed this type of reaction with the NaBH4. Same in the ester. Here please observe R C double bond O O M E methyl. Here Me means methyl ester compound. This ester compound on reaction with the excess La. Here also excess La in presence of water solvent. Here cleavage of this methoxy group, it converted as methanol compound and alcohol is produced from this reaction. Is it clear all of you? This is only this type of reaction proceeds with use of La. This type of reaction not possible with the sodium borohydride. Mechanism part of that particular reaction. Mechanism part. Here please observe. The mechanism for reduction of ester involves the transfer of hydride two times. Here please concentrate. La, aluminum tetrahydride. From this aluminum La delivers H minus nucleophile attacks on carbonyl carbon. H minus nucleophile attacks on carbonyl carbon. Immediately cleavage of that particular pi bond, oxygen gets negative. Here also same. This is the alkoxide ion intermediate. From this alkoxide ion intermediate, here this is an extra step. This particular leaving group removed from the intermediate. Loss of leaving group here. This is the extra step. We discussed in the last reaction also same, but here attacking of this La two times, hydride ion transfer two times H minus ion, here attacking on carbonyl carbon. This is the first step, and second after loss of leaving group, this methoxy leaving group. Is it okay? How is it? This pair of electron shifted to this side, immediately loss of methoxy leaving group. Expulsion of an alkoxide ion causes the carbonyl group to reforms. Here, this is the starting same reform as a carbonyl group. It may be aldehydic functional group. This compound immediately attacking H minus, another law delivers H minus ion attacks on carbonyl carbon or aldehydic carbon. Okay, from that immediately breakage of pi bond, oxygen gets negative. Okay, oxygen gets negative charge. Here we are representing two red color hydrogens. We are representing with a separate color, red color hydrogen. These two hydrogens H minus nucleophiles attacks on carbonyl carbon in two steps. This is the first step, attacking of nucleophile H minus nucleophile, and second step here another H minus nucleophile attacks on carbonyl carbon. Two hydrogens attacks on carbonyl carbon. After that, O minus oxygen, O minus negative charged oxygen abstract hydrogen from water molecule, water solvent. This reaction here, nucleophilic attack, two steps, two times. First time nucleophilic attack, second time nucleophilic attack. Okay, in the same reaction. Here that O minus abstract hydrogen from water molecule. This is the proton transfer reaction, proton transfer step. The resulting alkoxide ion is then protonated to form an alcohol. Finally, after abstraction of hydrogen from water molecule, it converted as alcohols. Finally, we are getting monohydric alcohols. Monohydric alcohols. Is it clear, all of you? This is the clear mechanism part of that particular uh, law reaction with the use of law reducing agent. Is it clear, all of you? Based on this law reducing agent, it can also used with the esters or carboxylic acids converted into alcohols based on this law. Okay, esters and carboxylic acids does not undergoes reduction reaction with the sodium borohydride. Okay, is it clear, all of you? Okay, we'll meet tomorrow at the same time with a new topic. Okay, students, thank you one and all.